Hi, welcome to another edition of mini lectures in pre-calculus. Today's topic is a short and important topic, reference angles in degrees, problems type 1 and 2. So what's the idea here? Suppose an angle that is given to us and it's not one of those comfortable angles between 0 and 90 degrees. Rather, it can be anywhere. It can be any number. We want to deal with this angle. We want to find out sine, cosine, etc. And one of the easiest way of dealing with this thing is with the concept of reference angle. Reference angle, so we have our standard coordinate system. Some angle is considered. This angle can be in the first quadrant, it can be in the second quadrant, it can be in the third or fourth quadrant, and we want to deal with this angle. The angles that are comfortable for us to think about are the ones between 0 and 90 degrees. So we convert our angle to another one which we call reference angle. How is that defined? Well, if you're in the first quadrant, that is, the terminal side of the angle is in the first quadrant, then this acute angle between the x-axis and the terminal side is called the reference angle. If the terminal side is in second quadrant, then this angle is the reference angle. Again, the reference angle is an acute angle. It's between the terminal side and the horizontal line. If you terminal side is in the third quadrant, then this is the reference angle. And if you're in the fourth quadrant, then this is the reference angle. So reference angle is the angle between terminal side So remember, we are putting the angle in the standard position. We are starting it off of the x axis. We have some angle given to us, and then this angle is always an acute angle. Excuse me. Reference angle between terminal side. Let me finish the sentence. Between the terminal side and the horizontal line. And it's an acute angle. So that's an important thing. We want to convert our angle to something between 0 and 90 degrees. Let's practice this thing in several examples and see how it works. So here is our first angle. We have an angle of 100 and minus 20 degrees. Question is, what's the reference angle of that? Let's try to visualize where this angle is at. Minus something means we are going in a clockwise direction. Okay, clockwise direction is we are going to go through 0, minus 90, minus 180, minus 270, and by the time we come back here, we are at minus 360. So where is minus 120? Minus 120 will be somewhere here, is that right? So we have opened this angle of minus 120 is between 90 and 180. Now what's the reference angle of it? Reference angle is whatever is left until we hit the horizontal. This is the reference angle that we have in mind. Well, how much is left to make it to the horizontal? So that's of course 60 degrees. The reference angle here has to be 60 degrees. So reference angle is always some, let's call it angle, say theta prime. The original angle is theta, the reference angle is theta prime. theta prime is always between 0 and 90 degrees. Okay, so we are making an acute angle so that when we want to apply the trig functions to it, it will be easy for us to answer those type of questions. Let's go look at this problem one more time. Suppose you don't feel all that comfortable with minus negative numbers. How about minus 120? Here's a simple trick that you can make it positive. Take your negative angle and add 360 to it. So of course now you make 240. What does that mean? It means we are reaching the same terminal side, but this time we are traveling in positive direction. If I want to go this way, it would have taken me 240 degrees to go. Okay, so negative meant I'm going down here in the clockwise direction, minus 120, I end up here. What if somebody wants to go in the counterclockwise and arrive at the same location? Well, he has to go through 240. How do I get to 240? I add 360s to it until it becomes a positive number. Then that's the angle I want to go. Once I make it to 240, how do I find my reference angle? I say, well, 240, I have passed 180. How much extra I have gone? So I say 240 minus 180 is 60 degrees extra past the horizontal line I have gone, and that is my reference angle. Okay, so we remember two things. If you are comfortable going through negative numbers, that's very good. So you say my negative number is 0, minus 90, minus 180, minus 270, and I come back to minus 360. I'm going in the negative direction, which is clockwise direction. If I want to go in counterclockwise, a positive direction, for whatever reason, if I want to go this direction, well then of course I have 0, 90, 180, 270. By the time I come back is 360. I'm going this way. So this is counterclockwise. One way or another, I choose one of these two to go. And wherever I stop, I ask myself, what's the angle I have made with the horizontal line? I always give my final answer between 0 and 90 degrees. So reference angle of some arbitrary angle theta is an acute angle between terminal side and the horizontal line. It has to be always between 0 and 90 degrees. So let's go another example. What's the reference angle for 105? Well, 105 thankfully is positive. We don't have any problem with positive numbers, hopefully. So I quickly think that I'm going 90 degrees here, and 105 I'm going a bit extra, and this is where I stop. So this is 105. Well, how much is left to the horizontal? So 180 minus 105, and this is 75. So this is 75. Of course, we don't want to make life hard for ourselves and make this thing negative and come here and do it, but if necessary, we would have done that as well. How about this one? Well, this is negative, so we have no choice. So negative minus 160, minus 160. So again, quickly, 0, minus 90, minus 180. So this is almost hitting, coming close to this. Minus 160, it's minus 160. How much is left to make it to horizontal? Well, take the numbers and subtract. So 180 minus 160, I have 20 degrees left to go. So the answer is 20 degrees. What if I wanted to deal with positive numbers? Well, I want to go this way. If I want to go that way, how much would it take? I have minus 160, I add 360s to it until it becomes positive. So this becomes 200 degrees. So this is 200. 200, let's redraw the picture. 200, I'm going 0, 90, 180. I'm stopping at 200. 200 is here. 200 is here, so the extra I need to go becomes 200 minus, we just passed 180. How much did we pass it by? By 20 degrees, and I get the same answer. Let's try another one. Minus 75 degrees, so minus 75 degrees. I am going in what direction? I'm going in counterclockwise direction, so I'm going in, well, remember, 0 and minus 90. We don't even make it to the vertical line. We're just stopping very short. It's minus 75 degrees. Okay, minus 75 degrees. Well, we are always interested in the positive angle between the terminal side and the horizontal line. Well, what is that? Well, that is just plus 75. So it's just 75 degrees. So the answer has to be always positive and less than 90 degrees, just so that it's comfortably one of those triangles that we always deal with triangle trigonometry. And what else? We have, say, 255 degrees. 255, where is 255? Can you quickly figure that out before I actually draw this thing? So what do we do? 0, 90, 180, this is 270, so this is going, not making to this vertical yet. This is where it stops at 255. So what do? I want to figure out what is the extra. So 255 minus 180, and I have what, 75 degrees past horizontal. That's where I stop. Okay, type 2, I compressed this two types in one lecture, so the lecture doesn't become super short. What if our angle is past 360? What do? Like, excuse me here, 700 degrees. Where is 700 degrees? So this is a little bit overboard. Meaning what? Meaning, well, I go 0, 90, 180, 270, 360. I still haven't hit 700, so I've gone one whole circle. I'm not there yet, so keep going. 450 after 360, add another 90 becomes 450, and perhaps another 90 to that, it becomes 540, and then what is that? 540 and 90 will be 630. By the time we come back here, we are at 720. Okay, so 630 doesn't do it. 720 is extra, so I've gone through this whole circle and come here. At 700 I'm stopping. At 700 I'm stopping. So, well, how much is left? We always calculate to horizontal. How much is left, or how much we passed the horizontal? Well, of course, 720 minus 700, we have 20 degrees left. So the answer here is 20 degrees. So how can we make a process for this? Take your number, subtract 360 from it. So now I have what is left. So I have, let's see, 200 and, excuse me, 340 degrees. Now 340 is like the problems we had done of type 1. That is, you figure out 340 is in quadrant 4, 20 degrees short of final horizontal line. So you subtract 360 from it. You keep subtracting 360 until you get a number between 0 and 360. And then you say, well, let's start all over again. 340, I'm going all the way, not the complete circle. Okay, I'm past through this vertical line. I'm in the fourth quadrant. I am still a bit short. And how much am I short by? I say 360 minus 340. I'm short by 20 degrees, and that is where our reference angle is going to be. Let's do one more time. 600. So if you want to do it like this, 600, you take it and subtract 360 from it, see what you get. So this time I get 240. So 240, so we subtract enough 360s out of it until we have an answer between 0 and 360. And then we ask about 240. So 240, I have gone through this half circle after this is by now we have gone 0, 90, 180, but we haven't made it to 270 because I'm supposed to go 240. So I'm stopping here. Well, how much have I passed the 180? So I say 240 minus 180. I'm 60 degrees over, so the answer here is 60 degrees, and so on. How about minus 540? So you notice you always have many ways of getting to your answer. However you do it is fine. If you're comfortable with negative numbers, just go around like that. If you want to convert it to positive, say minus 504. Add 360 to it. So what do I get? I get minus 2, let's say 360, 4 and 4, and I have 100, so I was making a mistake going. So I have minus 144. I have minus 144. Minus 144 is still negative. If you don't like negatives, all you do is you keep adding 360s to it until it does become positive. So I have, let's see, 144, 6, 1, and then I have 216 degrees. So now I ask myself, so what did I do? I started in my number, kept adding 360s to it until I get a positive number. Now I say 260. Where is 260? 0, 90, 180, and then I'm going a little bit extra. So 216 minus 180, and what is that? 336 degrees. So this becomes 36 degrees. Okay, so here type of problems we had. Of course, in this problem, you could have done it by going through the negative angles as well. So let's do that as well. 0, minus 90, minus 180, minus 270, minus 360. So we are not there. If you are going this angle, we have made it to minus 360. We still have ways to go. We come down to minus 450. So another 90 after this. That's still not it. Then another 90, it becomes minus 540. Well, now we passed where we want to be. We are going to be at 504. The angle is at minus 504. So what do? I subtract these two. I want to find this reference angle. So I take the 540, subtract 504 from it, and I get 36 degrees. Always a positive number between 0 and 90 degrees. Okay, let me leave a little side problem for you. And you're not going to see it in your homework or text problem. What if you had a number that was huge? So suppose I have an angle, say 10,000 degrees. Of course, going around circle is grass starts to grow by time we are between 0 and 360. So We want something a little bit more practical than just going around circle. And what if my angle was negative minus 10,000 degrees? Okay, so I'm leaving this type of problems as a challenge for you. If you are interested, you solve it, you let me know. And it just you want to know if you're interested in this type of topic or not. If so, you want to pursue mathematics a little bit more than what the text itself or the course itself requires. So you take a problem that you have in front of you, to try to generalize it, go to the extremes, uh, let your mind wander what other questions could be out there, what else is connected to this, how do I do it if it was this way or that way. So that important thing for you in a university is find out what is that you like. And of course, for us to figure out who has interest in this topic of mathematics and guide them to more courses. So you let me know and then I will talk. So, okay, so this final thing is just icing on the cake. It's not for grade, it's not for anything, it's just something you like to do. If you like to do, you let me know. Okay, so we learned about reference angles so that we can handle our trig functions perhaps a little bit faster and more intuitively than just keep going around in a circle. So until next time, good luck and